Electrical wire is commonly rated for a specific temperature. These ratings are generally 60 degrees Celsius, equivalent to 140 degrees Fahrenheit, 75 degrees Celsius, equivalent to 167 degrees Fahrenheit, or 90 degrees Celsius, which translates to 194 degrees Fahrenheit. This temperature rating defines the maximum temperature the wire can endure safely without experiencing degradation or posing a fire risk. Homes constructed before 1985 may incorporate 60-degree rated wire. This type of wiring is often no longer considered safe for contemporary electrical applications. The recommended standard for new electrical installations is often 90-degree rated wire. This is because of its ability to withstand high temperatures, reducing the likelihood of electrical fires. Ensuring the use of the correct wire size and temperature rating for specific electrical applications is critical. The use of wire that is not rated for the appropriate temperature carries significant risks and could potentially result in a fire. When selecting electrical wire, there are several factors to consider, including the amperage of the circuit, the voltage of the circuit, the type of insulation, and the temperature rating. It's important to choose a wire that is properly sized for the amperage of the circuit. If the wire is too small, it can overheat and cause a fire. The voltage of the circuit is another important factor to consider when choosing electrical wire. Be sure to choose a wire that is rated for the voltage of the circuit. The type of insulation is another important factor to consider. Some types of insulation are better suited for certain applications than others. For example, THHN wire is a common type of wire that is used in residential and commercial wiring. It is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. TW wire is another type of wire that is used in residential wiring. It is rated for 60 degrees Celsius in wet or dry locations. The temperature rating of the wire is also an important factor to consider. Be sure to choose a wire that is rated for the temperature of the environment in which it will be used. For example, if the wire will be used in a hot environment, be sure to choose a wire that is rated for 90 degrees Celsius. Here's a more detailed look at each of these temperature ratings. 60 degrees Celsius wire is typically used for general-purpose wiring in residential and commercial buildings. It is the least expensive type of wire, but it is also the least heat-resistant. 75 degrees Celsius wire is a good choice for applications where the wire may be exposed to high temperatures. It is more heat resistant than 60 degrees Celsius wire, but it is also more expensive. 90 degrees Celsius wire is the best choice for applications where the wire will be exposed to very high temperatures. It is the most heat resistant type of wire, but it is also the most expensive. It is essential to adhere to the National Electrical Code or NEC guidelines when installing electrical wiring. The NEC provides comprehensive standards for safe electrical installations, addressing wire types, sizes, and temperature ratings for various applications. Referencing the NEC ensures compliance and minimizes potential hazards. For example, NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts, with temperature ratings of 60 degrees Celsius through 90 degrees Celsius. This table is essential for determining the correct wire size based on its ampacity and temperature rating. Furthermore, NEC Section 110.14c addresses the temperature limitations of conductors. It states that the temperature rating associated with the ampacity of a conductor shall be selected and coordinated to not exceed the lowest temperature rating of any connected termination, conductor, or device. This means that all components in an electrical circuit must be rated for the same temperature to ensure safe operation. When working with older homes that have 60 degrees Celsius rated wiring, it's crucial to exercise caution and consider upgrading the wiring to meet current safety standards. Over time, the insulation on older wires can deteriorate, making them more susceptible to overheating and causing fires. Upgrading to 90 degrees Celsius rated wire can improve safety and ensure that the electrical system can handle the demands of modern appliances and electronics. In summary, understanding electrical wire temperature ratings is essential for ensuring electrical safety. Always choose the correct wire size and temperature rating for your specific application and adhere to the NEC guidelines. When in doubt, consult with a qualified electrician to ensure that your electrical system is safe and up to code. When dealing with electrical wiring, it's crucial to understand the different types of insulation used and their corresponding temperature ratings. Firstly, thermoplastic high heat resistant nylon coated or THHN wire is a common type used in residential and commercial buildings. It's rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. This wire is known for its durability and resistance to heat, moisture, and abrasion. Secondly, thermoplastic heat-resistant, water-resistant or THW wire is another type commonly used in residential wiring. It's rated for 75 degrees Celsius in both wet and dry locations. THW wire is suitable for general-purpose wiring and is often used in conduit or other protected raceways. Thirdly, thermoplastic high heat-resistant, water-resistant or THWN wire is similar to THW wire, but has a higher heat resistance rating. It's rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THWN wire is often used in applications where the wire may be exposed to high temperatures or moisture levels. And fourthly, cross-linked polyethylene or XHHW wire is a type of wire that uses a thermoset insulation material. It's rated for 90 degrees Celsius in both wet and dry locations. XHHW wire is known for its excellent electrical properties, heat resistance, and moisture resistance. When selecting the appropriate type of wire for a particular application, it's important to consider the environmental conditions and the temperature requirements. If the wire will be exposed to high temperatures or moisture, it's essential to choose a wire with a suitable temperature and moisture resistance rating. Additionally, the wire size must be appropriate for the amperage of the circuit to prevent overheating and potential fire hazards. To further illustrate the importance of using the correct wire size and temperature rating, let's consider a few examples. Firstly, imagine an older home with 60 degrees Celsius rated wiring. If a new appliance, such as a high-power microwave, is plugged into a circuit with this older wiring, the wire may overheat due to the increased current demand. This overheating can cause the insulation to break down, leading to a short circuit and potentially a fire. Secondly, consider a commercial building with 75 degrees Celsius rated wiring. If a new lighting system is installed that requires higher operating temperatures, the existing wiring may not be able to handle the increased heat load. This can result in premature failure of the wiring and potential safety hazards. Thirdly, in industrial settings, 90 degrees Celsius rated wiring is often used due to the high temperatures generated by machinery and equipment. If lower rated wiring were used in these applications, it could quickly degrade and pose a significant fire risk. In addition to temperature ratings, it's also important to consider the ampacity of the wire. Ampacity refers to the maximum amount of current that a wire can safely carry without overheating. The ampacity of a wire is determined by its size, insulation type, and the ambient temperature. The NEC provides tables that list the allowable ampacities of different types of wire under various conditions. These tables are essential for determining the correct wire size for a particular circuit. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors with temperature ratings of 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. This table takes into account the wire size, insulation type, and ambient temperature to determine the maximum current that the wire can safely carry. When selecting wire for a particular application, it's important to choose a wire size that has an ampacity equal to or greater than the circuit's overcurrent protection device, such as a circuit breaker or fuse. This ensures that the wire will not overheat if the circuit is overloaded. Over time, electrical wiring can deteriorate due to age, environmental factors, and other causes. It's important to periodically inspect electrical wiring for signs of damage, such as cracks, fraying, or discoloration. If any damage is found, the wiring should be replaced by a qualified electrician. Another important aspect of electrical safety is proper grounding. Grounding provides a safe path for electrical current to flow in the event of a fault, such as a short circuit. A properly grounded electrical system can help prevent electric shock and reduce the risk of fire. The NEC requires that all electrical systems be properly grounded, and it provides detailed guidelines for grounding electrical equipment and wiring. This includes grounding electrodes, grounding conductors, and bonding techniques. In addition to grounding, it's also important to use ground fault circuit interrupters or GFCIs in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect even small amounts of current leakage and quickly shut off the power to prevent electric shock. They are a valuable safety device that can help protect people from electrical hazards. Furthermore, surge protection is also essential for protecting electronic devices from voltage spikes. Surge protectors are designed to absorb excess voltage and prevent it from damaging sensitive electronic equipment. Voltage spikes can occur due to lightning strikes, power outages, or other electrical disturbances. Surge protectors can help prevent costly damage to computers, televisions, and other electronic devices. In addition to these safety measures, it's also important to follow some basic electrical safety rules. Firstly, always turn off the power before working on electrical circuits. Secondly, never overload electrical outlets or circuits. Thirdly, keep electrical cords and wires away from water. Fourthly, never use damaged electrical cords or equipment. Fifthly, if you are not comfortable working with electricity, always hire a qualified electrician. By following these electrical safety rules, you can help protect yourself and your family from electrical hazards. Remember, electricity is a powerful force, and it should be treated with respect. In summary, electrical wire temperature ratings, ampacity, proper grounding, GFCIs, surge protection, and basic safety rules are all essential components of a safe electrical system. By understanding these concepts and following the NEC guidelines, you can help ensure that your electrical system is safe and reliable. When choosing wire for an electrical project, it is crucial to consider several factors beyond just the temperature rating. Firstly, you need to determine the correct wire gauge or size. The wire gauge is a measure of the wire's diameter, and it directly affects the wire's ampacity or current carrying capacity. The smaller the gauge number, the thicker the wire, and the higher its ampacity. The NEC provides tables that specify the allowable ampacities for different wire gauges based on their insulation type and temperature rating. Secondly, consider the type of wire. There are several types of electrical wire available, each with its own unique properties and applications. Common types include THHN, THW, THWN, and XHHW, as previously mentioned. Each type has its own insulation material, temperature rating, and moisture resistance. The choice of wire type depends on the specific application and the environmental conditions. Thirdly, take into account the voltage drop. Voltage drop is the decrease in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop, and it recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Fourthly, think about the installation method. The way that the wire is installed can also affect its ampacity. Wires that are installed in conduit or cable trays may have a different ampacity than wires that are installed in free air. The NEC provides tables that specify the ampacities for different installation methods. Fifthly, make sure to use the correct connectors. The electrical connectors are used to join wires together or to connect wires to electrical devices. It is important to use connectors that are rated for the wire size and type being used. Using the wrong connectors can lead to loose connections, overheating, and potential fire hazards. And sixthly, always follow the NEC guidelines. The NEC is a comprehensive set of standards that governs the safe installation of electrical systems. It is essential to follow the NEC guidelines when installing electrical wiring to ensure safety and compliance. When working with electrical wiring, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge and experience to safely and correctly install electrical wiring. They can also help you choose the correct wire size, type, and connectors for your specific application. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or even death. Always prioritize safety when working with electricity. Before starting any electrical project, turn off the power at the circuit breaker or fuse box. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate safety gear, such as rubber gloves and safety glasses. And never work on electrical wiring in wet or damp conditions. By following these safety precautions, you can help protect yourself from electrical hazards. Understanding the concepts of series and parallel circuits is crucial for understanding how electricity flows through a circuit. In a series circuit, components are connected end to end, so the current flows through each component in turn. The total resistance of a series circuit is the sum of the resistances of all the components. In a parallel circuit, components are connected side by side, so the current has multiple paths to flow through. The total resistance of a parallel circuit is less than the resistance of the smallest resistor. Understanding the difference between series and parallel circuits is essential for designing and troubleshooting electrical circuits. It is also important to understand the concepts of alternating current or AC and direct current or DC. Direct current flows in one direction only, while alternating current reverses direction periodically. Most household electricity is alternating current, while batteries provide direct current. Understanding the difference between AC and DC is essential for working with electrical circuits and devices. In addition to understanding these fundamental concepts, it is also important to be familiar with the tools and equipment used in electrical work. Common tools include wire strippers, pliers, screwdrivers, voltage testers, and multimeters. It is important to use the correct tools for the job and to use them safely. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. It is an essential tool for troubleshooting electrical circuits. To summarize, the temperature rating of electrical wire is a crucial factor to consider when selecting wire for an electrical project. It is important to choose a wire that is rated for the temperature of the environment in which it will be used. In addition to temperature rating, it is also important to consider the wire gauge, type, voltage drop, installation method, and connectors. It is always best to consult with a qualified electrician when working with electrical wiring, and always prioritize safety when working with electricity. Remember to follow all NEC guidelines and use the correct tools and equipment for the job. By understanding these concepts and following these safety precautions, you can help ensure that your electrical system is safe and reliable.